think my content is somehow very similar with Professor Wen Yunggang's presentation. Maybe give you more information about the AI for sustainability and also what can we do for the sustainable AI. Yes, of course. When we talk about the sustainability, we always talk about the SDGs. Then AI is very actually a useful tool for the SDG. And China also put a lot of efforts, emphasize on the SDG development, especially, I think maybe I can have this one. Wait, okay, I have this one. China has did a lot of things addressing the sustainable development issues, and some of them are quite related to the energy saving and the low carbon transformation. So talking about the AI for sustainable governance or sustainability, we can actually figure out some kind of contribution. For example, by using the AI, we can get better or more accurate predictions, and we can get sharper identifications about the characteristics or the smarter decisions and the effective control. So that means that actually we have a lot of challenges in the activities tackling the climate change. For example, we have to do a lot of system optimization, like our experts from YASA. And we also have a lot of studies for like the hybrid physical modules, a lot of things in the fields of the climate change. And on the other hand, we can find out many AI technologies can help us to solve such kind of problem. For example, the time series like LSTM, the reinforced learning, or a lot of such kind of like computer vision, such kind of AI tools actually can help us to solve the problems or solve the help us to provide better solutions for the climate change. I think we better turn off the lights because my background is
The side ones work.
Oh, really? But I cannot identify. Okay. Yes. That's what we have done. For example, we can use the AI to improve the operation efficiency and also the resilience of the energy system. We use the machine learning technology and to try to remove the peak loads and to make the electricity system more stable. This figure actually show you the effect. We can make a flatter load curve by using the AI machine learning. And for example, here, actually, we use the agent-based module and to look at the regional power market by using the multi-agent reinforced learning to look at the electricity market, whether we can have a better learning effect by increasing the penetration ratio of the renewables. We can also use the AI for the sustainable cities and the communities. Like here, we actually use the machine learning to make a better prediction of the energy demand for an aging society. We use big data and the machine learning to identify the pattern of the household electricity use, very high frequency electricity use data, and to look at in the aging society, what can we identify regarding the aging populations. And for example, here, we actually use the machine learning to look at the risk prevention of the epidemic transition in a digital societies, based on the communication data. That's for the COVID-19 period. So such kind of AI technologies actually can be very useful. We can also use the AI for the sustainable production and consumption. For example, the deep learning-based organic reaction production predictions that have been widely started, and also a lot of the pollution monitoring or system optimization. For climate actions, also a lot of space. For example, this is the work we have done. We use the causal inference to look at the policy effect of the carbon market, whether they really have the efficiency improvement or have the emission reduction for the power units based on the causal tree. And we also use, like, you must know that we can, by using the machine learning, combining with lots of data, we can do better greenhouse gas emission monitoring or more frequent greenhouse gas emission estimation. Okay, and this is also very interesting work. We can actually use the like transformer structure module, like what is exactly same as the large language module. We can use that to make a better forecasting regarding the weather or season fluctuations. They must be very, very essential or critical for the renewable energy supply, right? So this is try to show you the using such kind of machine learning to, combining with some other data, we can do a 15-day global weather forecast, much better than the normal module. And this is another very interesting findings just published on the scientific data. We use the natural language processing technologies and build up the largest database regarding the climate policies. And we combine lots of data sources, either from the government, the websites, or from the internet, from social media, and to build up the world's largest policy database for the climate change. And by using the database, you can see, because it's a long-term policy database, we can look at the network of the policy development. We can look at the diffusion processes of one policy. For example, the EU ETS is the pioneer. Then how many countries follow their policy design, and how can we learn more from the European experiences? We can observe lots of such kind of characteristics. Okay, this is what AI can do for the climate change. But on the other hand, a lot of evidence have been shown by Professor Wen. AI also brings huge growth in the power consumption, right? Like the similar figure, the estimated energy consumption for the various AI-powered systems compared to the standard Google search, you can see very large increase. And also for training the large language models, here I show you the similar in like GPT-3 or some other large language models, we can say with the increase of the number of parameters, then energy use could increase very greatly. So that means that the AI actually brings very huge increase in the power consumption. If you look at NVIDIA's data center GPU shipment in 2013, we can see very explosive growth, right? And it is estimated that from 2025 to 2029, the electricity consumption caused by AI will increase from 100 terawatt to nearly 400 to 400 terawatt. So that's very great increase. If you look at this is the NVIDIA GPU, Google TPU, and all the other TPU, GPU, FPGA, the energy use and the number and also their carbon emissions. And how about China? So we can observe that in 2020, the power consumption of the IDC actually, will reach almost 207 billion kilowatt, accounting for about 3% of total social energy consumption. Of course, this number will increase gradually. So this is some interesting focus. And if you look at the number of the total trends of the computing power demand, we can also see a very rapid increase in terms of the computing demand in China. And also in different provinces, we can observe some provinces, their computing demand increased very dramatically, especially many provinces in eastern coastal areas in China. So that means that the total number of the data center actually have the standard racks, which with the average annual growth of more than 30% in the past 5 years. This is great, I think very amazing number, right? This is computing resources in China and also the number of the racks in use in the IDCs. But if you look at the geographical distribution of the IDCs, we observe great imbalances in terms of the IDCs. So here you can see more in the east and less in the west in terms of the IDC. The IDC are mostly distributed in the eastern coastal regions and few in the central and the western regions. So that's the existing situation. That means that we have to think about the imbalance in terms of the renewable resources and also the distribution of the IDCs. And we can also see that actually most of the data centers are mainly concentrated in the developed regions in China. And they have very concentrated technology industries, such as the Bohai area or the Yangtze River Delta and also the Pearl River Delta. But if you look at the future deployment trends, the western region is gradually becoming a new hotspot for the data center. We have published a kind of national planning for the data center distribution. So in the future, the western regions will become the hotspot for the data center. So that gives us a space for the optimization. I mean that this is about the PoE because time is limited, so I will not go into detail. But in general, the PoE, the performance of the PoE in China is not that good and also imbalanced, I should say. But as I mentioned that because the imbalance of the IDC distribution and also the very great endowments of the renewable resources, we have space for the renewable energy and the co-optimization of the renewable energies and also the IDCs. So here we can see that the distribution of our solar and wind energy quite concentrated in the northwest of China. So that's why we have large space for build up a greener electricity system for the IDCs. So that's why we can actually have from supply side to the distribution of electricity, the green electricity, and to the computing power demand, we can do a systematic optimization in terms of the computing demand, computing resources, and the renewable resources. That's our basic suggestion. So that's why we actually can coupling the power grid and the computing power networks together. The power network and the computing network can be optimized together. So what's the objective function? Of course, on one hand, we want to minimize our carbon emissions, and we also want to minimize our construction and operating cost of the IDCs. And also, we have to meet the power, the computing demand for the large language models or other AI industries. So that's the dual objective optimization of the economy and the carbon emissions. Of course, there have been some case studies regarding the coordinated optimization of the computing power resources and the demand and the green electricity. Then we can see that actually the co-optimization of the minimum IDC cost and the maximize the renewable energy utilization could significantly reduce the PoE of IDC. So that gives us some interesting implications. And we also can find some other case. That means that if from the central government, they can do a systematic optimization regarding the renewable resources and the IDCs, when we can also achieve a better performance in terms of carbon emission. So this is a scenario study based on the zero carbon emission targets, and how can we optimize the distribution of the IDC in China. This is some our empirical studies and also our thinking about the sustainable AI. Thank you.